tolerance. Don't forget about precision and uncertainty, but I'm kind of like putting it on hold, okay? So if you have a highlighter, this is where you want your highlighter. Okay, so tolerances. Okay, when building or assembling any object, from a simple bookcase to a complex computer, you must take measurements. Your measurements should always be accurate as possible, and they should be precise enough to meet the needs of the project. When manufacturing a product, watch this. A range of sizes are often acceptable. Highlight that part on 92. For example, if you're making a mortise and a tenon joint, as shown in the diagram, the tenon needs to be small enough to fit. Watch this. Tenon needs to be small enough to fit into the mortise, but large enough that it will not fall out. The range of acceptable values is called tolerance. Very, very important right there. If I ask you for the definition, and you know what, I won't say, hey, which one is the definition? I will probably give you scenarios, and you tell me which scenario is really talking about tolerance. Okay. And you probably have no idea what a tenon and what a mortise is, do you? I don't blame you. So the mortise is that the hole that is created there. So if you want to have an arrow, I don't know, I bet you it's called mortise or something like that, but I'm pretty sure it's called mortise. And that's the tenon. And I will also box in the tolerance here because it's, again, talking about tolerance, and it just gives you another version of it. It's the allowed variations for the intended purpose. And another important, we're on page 92, Marcy. Another important one is nominal values, the target value of measurement. It's what we're after. Spillage. Okay. We're okay there? There's some paper towel there if you want to grab that. Okay. Why would we have tolerance in an industry? Why would we allow for different? So let's say when I worked at KitchenCraft, this is just a random example. I was in charge at first of a rip saw, which was like the blades would move and I had to like calibrate all of that, and the blades would move. It would scan the board. There's a camera that scanned the board, and then that camera would see like the imperfections in that board and try to cut it out. Like the blades would there were like 7 blades in there, and that machine would just like move and it try to rip out that defect. And one of the pieces that we were after had to be 45 millimeters wide. That was my nominal, my target. Okay, target or the nominal. And what do you think happened when I measured most of the pieces coming out of that rip saw? Do you think they were every single one of them was 45? You think? If you're working with wood, do you think you're always going to make a perfect cut? You're going to be off by a little bit, right? So what they told me was like, okay, anything between 43 and 47 was acceptable, right? So this would be the min and this would be the max, right? This is the tolerance, like the difference. It could 43 was still acceptable, 47 is still acceptable. If it's not, I had to go back and recalibrate the machine. And the reason why 43 or 47 was acceptable is because those pieces went to another department that would machine them even further. So being off by a little bit wasn't a big deal. But otherwise, the machines, like the blades bend. Did you know that? They vibrate, they bend, they overheat. So there's always a little bit of anything in industry, whatever you make, like you grab any, like, have you ever looked at your mugs made in China? Right? Do you think they're always perfectly round? Do you think they always have the same diameter? I don't think so. If you were to actually measure it, they'd be off, but there's some tolerance because in production, there's always going to be a little bit of give and take. Always. There's always going to be a little bit of variation, right? And if you didn't allow for it, you would never get stuff done. So every industry has a bit of tolerance. They allow for things to be off by a little bit because of the production limitations. The machinery, whatever you're using has limitations, like the precision and the variation come into effect here. Precision and uncertainty, I meant to say that. But anyways, that's what we're going to be talking about. Like the tolerance here is acceptable value. So for example, what is something you could relate to a bit more? Your cases for your phones, right? They allow a little bit, like if my case was a little bit, if it was too small, it would just not go onto my, it would just not go onto my screen, right? If it's too big, my phone would drop out of the case all the time. So there has to be that perfect fit, right? But it allows for some tolerance, right? Like actually when you bend it a little bit, it allows for that tolerance to like wrap around your phone, right? If you work, oh yeah, this is a good one. I didn't do it because I was I was thinking I could get in trouble, but I used to do it where I would plug in a power cord and I brought my voltmeter and I actually measured the electricity coming in live, like with students in class. Maybe I'll do it. It's cool. What is the voltage coming out of the your socket? Do you know? 100. It's supposed to be 115, 120. Supposed to be. But when I measure with students, it's like all over the place. It's like 111, then it's 125. It's like it fluctuates. It's not always 115 what they're calling for, right? And so why is that? There's wires everywhere, right? Like transformers are in between and the turbines are not always spinning at the same rate and stuff like that. It affects everything. So your electronic devices, when you plug in your phone, the voltage coming into here is not 120. Sorry, it's a lot lower. It's probably, I don't know, 5, 6 volts. It fluctuates as well. So your phone, when they make it, they need to make sure they account for that. So your iPhone tolerates a little bit of a higher voltage and a little bit of a lower voltage. It will tolerate that. Otherwise, you would fry your phone, right? You would fry. Yeah, exactly. So there's tolerance for everything. You don't think of it. You're just like this. You just plug it in, right? But if you don't account for that in the industry, there's going to be a lot of angry customers, right? My phone fried. Why did it fry? Oh, we didn't allow for the extra voltage coming in, right? We didn't account for that when we built the thing. So tolerance is everywhere. Yeah, go ahead. Runways, runways for airplanes. You think there's some tolerance? Well, they sure don't make them too short. The runways are, if anything, are going to be longer, but not shorter than a minimum requirement, right? So there are certain areas you can't go. For example, if you get your COVID vaccine, if the nurse gets it wrong and it's too low, like the dosage that you're drawing is too low, is that dangerous for you? If it's too low, it's not dangerous, right? But it sure is dangerous if you overdo it, right? Like what if the nurse goes double dose and oh, maybe you got your 2 doses maybe, but it could be dangerous, right? You could be overdosed. So there are certain industries where there's only tolerance one way, not both ways. So it depends on the industry and it depends on the scenario, okay? Did you know that some of the traffic lights have like something that senses if a car is over and waiting on the light? Some of those are weight activated. So if you as a person were to stand on the middle of the road, that thing would know it's not a car, right? Standing on or waiting for the light. So if somebody wants to fool around or just cross or whatever, it's not going to trigger it. They have plates beneath the pavement, and some are weight activated. Some of them, and the newer ones just have a sensor, right? I don't know if you've seen those by traffic lights. There's just like a white sensor pointing at that intersection. So I guess in Manitoba, it's not a good idea to do anything underground, right? Because everything shifts and probably breaks. Okay. There's another example for tolerance. The tolerance and temperature, right? I don't know if you've seen certain things should not be stored below a certain temperature, right? Medication has to have a sweet spot, right? Not too low, not too high, right? Dairy products, like in the fridge. You think your fridge is always the same temperature? No. Every time you open it, like my kids, they think it's a TV, right? Your parents probably yelled at you, right? You open it, temperature goes up in there. You close it, the motor has to work really hard to get it back to the temperature, the ideal temperature. But the food in there, right, it kind of needs to have a little bit of, there needs to be a bit of a tolerance, or else everything would spoil every time, right? So here we go. Tolerance is determined by subtracting, here it is. Tolerance is determined by subtracting the minimum acceptable value from the maximum acceptable value. So in a nutshell, tolerance is max minus min. And you might think, Mr. Dixon, wasn't that the range? Yes, it is the range, but tolerance is what we accept, the industry accepts, okay? When unknown, we assume that the nominal value, okay? When unknown, we assume that the nominal value is halfway between the minimum and maximum values, okay? This is going to be very rare. Like I will try to stay away from that because it's not always halfway in between. You're going to find out very soon that it's not always halfway in between. This is what needs to be on your study sheet, guys. Watch this, right? These, I'm not going to box them in because I'm going to add to this. This is very important, so now you need to wake up if you were kind of zoning me out there, tuning me out. Their tolerance can be written in 4 ways. 4 ways that industry could refer to tolerance, okay? So there could be a maximum and minimum value. So let's say it could be 27 degrees Celsius and minus 2 degrees Celsius, let's say. It could be stated like that, okay? It could be written like this, nominal value. So let's go back to my kitchen craft years, right? Nominal is the target. So they wanted me to have a piece of 45 millimeters, plus or minus half of whatever the tolerance is. So let's say the tolerance was 4 millimeters. Okay. I'm just giving you random examples, right? Another way of writing it is minimum value minus 0. Because think about it, if it's the minimum value, if it's the lowest value, you can't go any lower, but you can go higher, okay? So let's say it would be my kitchen craft example here, 43 millimeters minus 0 plus 4 millimeters, like that. Or it could be that they're giving you the maximum value. You can't go any higher, but you can go lower. So the maximum value, going back to my kitchen craft example, right? 47 is the highest. It cannot be any higher than that, but it could be lower by 4 millimeters. This is the kicker. This is where the province, and we had a big argument over that in one of the when we used to have provincial exams because they didn't tell us that. But they basically said that in every single case, the big number, this one doesn't have a big number, correct? This one has two big numbers. But if you have a big number in front like that, it's always the nominal. It's always the target. So sorry about these lines. They went a little bit too far. Okay? But I will make an arrow. So I'm going to write nominal or the target is always the front big number. So, Mr. Dirksen, what are you saying? Like, I thought once you're done writing this down, that's when I'm going to say it because otherwise you're not going to pay attention. I don't blame you. Write it down. So this is the nominal value, right? So obviously the big number, you should right away know, yeah, it's a nominal. I get it. I recognize that because the plus or minus half. I get it. But this one has minimum value. So I come up with the minimum. But Mr. Dixon, you're telling me that that's also the nominal, that's also the target, and the answer is yes. So in this particular case, you should recognize that if it's a -0, that this is the minimum, this is the lowest value you can get, but it's at the same time the nominal is what we're aiming for when they write it like this. Yeah, go ahead. And this one, you should recognize that this is a max because it says +0. But it is also the nominal. It's also what they're targeting. Okay, what this industry is targeting. They're actually targeting. It's saying, hey, we want 47. We don't want anything bigger. It could be smaller, but we don't want anything bigger than that. Okay, and that's what I want you to remember. So now let's practice this right away. I'm going to go straight into how do we work with this? What is the math behind it? And that's where the next page I put in a bunch of examples, and please follow. I know you can do it. You just need to like work through a couple of them and then you'll be champs. Okay? Yeah, okay. So here we go. I'm going to give you examples and then we're going to work through them. So let's say you have a scenario where it's max min. So we're going to go 15 centimeters, write this down on page 93, and 12 centimeters. So you have both values stacked like that, you know it's this case right here. And this is what I want you to know. Every single tolerance case has a max, has a min, has a tolerance, and it will have a nominal. Every single time you will be able to figure out all four of these in no particular order, but these four things can always be deducted from any way they state the tolerance. So what's the max here? Duh, Mr. Dirksen is 15 centimeters because that's the biggest number. What's the min here? Just follow me, okay? Because it's going to come in handy later. The min is 12 centimeters. That's the smallest they allow. What's my tolerance? Tolerance is max minus min, which we already did. We already figured these out, right? So it's 50 minus 12, which is 3 centimeters. Make sure you have units every single time. Okay. Watch for negatives. Double negatives are going to be like quite frequent. So you'll see that. Nominal, what's nominal? In this case, we're going to assume it's in between. We assume it is in between. If you don't know, if there's no big numbers solo standing in front of the whole thing, if it's like this is the only time you have to do this, is you go 15 plus 12 divided by 2. And that's 27 divided by 2, which is 13.5 centimeters. So we've got our max min tolerance. 13.5 is what we're aiming for. Okay, next here. Let's say we have 17.5 millimeters plus or minus 1/2 of 0.4 millimeters. You should immediately recognize, aha, we're in the tolerance territory. Okay, we're in tolerance territory. I recognize this is one of the 4 ways to state your tolerance. Every single time you're able to get your max, your min, your tolerance, and your nominal in no particular order. I just state them like that: max, min, tolerance, nominal. Yep.
Can you explain again how you got 0.4?
This is just an example.
Oh.
Yeah, this has nothing to do with the previous. Yeah. Yeah, nothing to do. So if you want to do this, right, every single one of them is going to be separate, right? Yeah, nothing to do with the previous. Good question. I want that to be clear. You would have your study sheet, right? I don't have one, but you would have your study sheet and you'd be like, this one seems kind of familiar. You should look this one up on your study sheet. And therefore, you know that this first number is my nominal. I'm just reading this. I'm not even doing any math there. What's the tolerance? Is it possible to just get it by looking at it? And you recognize that that's 0.4 millimeters. Done. Read. Yeah. You can see tolerance is in here. And that's what I state. The number that's in the brackets, when it's in this format, you will automatically know that that is the tolerance in this particular scenario. You just know because it's in that format. And I will not give you any other format, so you don't have to guess. It's not related to this one, Kim J, if you're true. Okay, it's not. What's the max and the min? So this is where you have to do a little bit more math. So 17.5 millimeters. We're going to go plus because it's max, right? So we're going to go plus half of 0.4. 0.4. Let me zoom into that a little bit. I can't do too much because then it's going to be off. So this is 17.5 plus, what's half of 0.4? Just divide it by 2, right? 0.2. And that is 17.7 millimeters. And what's my min? Half of 0.4. Remember, if you're multiplying something by half, it's like dividing it by 2, okay? If you're multiplying something by a third, it's like dividing it by 3. So this would be 17.5 minus 0.2, and that is 17.3 millimeters. So I had to do a little bit of math to get my max and my min. Okay, not a whole lot, but some is just reading, and some of them it would be, I love highlighters, you probably know that already. But maybe what I will do is I will do this and just say, I just got it straight from the source. And then 0.4, I got it straight from the source. I didn't do any math to just read it. Okay. One more. Well, two more. This is a scenario where you have something like this. Watch. So let's say it's 5 degrees Celsius, and it says plus 2 degrees Celsius up here, and then it's minus 0 degrees Celsius down here. So then you go max, min, tolerance, and nominal. Now, which one can we know right off the bat? You go to your study sheet. Can I say something before that? You're right, but this is the one I would focus on, the big number up front. What is that always? It's always my nominal right away. Boom. That's the first one I would state, like boom, you get a half a mark right there maybe. Okay. And then I'm going to focus on the rest. So watch this. If you have no idea what your max is, you just go 5 degrees Celsius plus, right, the 2. So that's 7 degrees Celsius. That's my max. Let's say you have no idea what the min is. Just basically read this thing. How much are you subtracting to get your min? 0, right? So it's 5 degrees Celsius. So you're like, Mr. Erickson, I have 5 here already. Yes. It happens to be both, right? It happens to be the minimum, but also the target. Target, put that down. Yeah.
You know how you show your work for the max and min?
You don't have to.
Okay.
No, you don't have to. Especially if it's that easy, just like state it. I don't know. I'm just thinking of an example for you. When you know that all the eggs, like, is it maple leaf? They actually have farmers that the eggs are laid at the farm, but then they bring all the eggs into the plant. Did you know that? And they just have them under like strict temperatures. And this could be a scenario where the eggs have to be at 5 degrees Celsius. It could be a little bit more, it could be 7, but it could not be less than that. So they would be like, this is what we allow. The tolerance is 5 degrees. It could be minus 0, but it could be plus 2. Okay. Tolerance, max minus min. So you have to go. Did you have a question, Coda? Did I ignore you? Did you have a question? Oh. Okay. And then when they hatch, they bring them back to the farm. Did you know that? Yeah, it's kind of weird, but they want to control the process of in between, I guess. So 2 degrees tolerance in this case. Some of you will be able to just read it like that. Some of you, I developed this so every time you can get it. Every time. Let's do, I still have some time. So here, 0, let's say you have 0.5. I think this is a COVID example. COVID dose. And then again, you will always do this. Max, min, tolerance, and nominal. Oh, don't use too much room. I want to give you one more underneath, a weird one. So just leave a little bit of room underneath. That's going to be an oddball. You're going to have some oddballs but it still works every time. What am I going to get you to focus on? If there's a big number up front, put that down for your nominal right away. At least you've got something, right? You know? And then your max, well, it's 0.5 plus 0, I know you're like, why, Mr. Dixon? Why do you go through that? Because it's still accurate. You're still answering the question. You're adding to get the max. And to get your min, we take the 0.5 minus the 0.1. So that's 0.4 mLs. And what's my tolerance? You take your max, you take your min, you subtract them. So it's 0.1 milliliters. Boom. You answered everything you need. And you know what the beauty is now? You might not think it's beauty, but these four, once you have these four, how many ways are there to write your tolerance? There are four. Once you have them all four like categorized, you can now branch off to any one of those formats and rewrite it. It's kind of like you're like, okay, I have everything I need. I can go to any one of those four and rewrite it. One last example, and that'll be it for today. That'll be it. Okay, so this is the oddball here. This is the one that might throw you off a little bit. Maybe not. Maybe not. So you got to go max, min, tolerance, and nominal. Which one are you going to state first? The big number up front is what we're targeting. So that's our target. Same as always. You got this. What should I do next? Well, I would do max and min. So max, notice that there is no minus 0 or plus 0, right? So this is one of the oddballs. So 45.05 plus 0.02 is my max. 45.05 minus 0.03. So I basically just subtract whatever is there, whatever it has a minus in front of it, you subtract it. Whatever has a plus, you add that. So this gives you 45.0. The 5 and the 2 give you 7. Make sure you have units at the end. I don't care about in between, but at the end. That's 45.02 here. But we're not done yet. We're going to go max minus min to get our tolerance. Can you tell your tolerance just by looking at this? Right, you're going from -3 to +2, so it's like a 0.05 centimeter tolerance. Thank you guys. More tomorrow.